Welcome to Phillips Tech. Today I'm going to look at what writing really is from a scientific viewpoint, including the band of light visible to the human eye and how, as humans, we see light. As well as this, I look at the progression in lighting technology through time, starting with early prehistoric lighting to the present day. The idea of light did not arise until 900 AD with the study of optics in Arabic natural philosophy. But the idea of measuring light had not really been looked at until the study of photometry by John Lambert in 1760. This study looked at measuring light and assessing the quality of light sources illuminated. It looked at different formula used to calculate how light waves behave, along with formula to aid in lighting design. What is light? Light is a band of frequencies of radiation on the electromagnetic spectrum called visible light. It consists of the colours of the rainbow: red, orange, yellow, green, blue, indigo and violet, which, when mixed, creates white light. These wavelengths range from 0.0004 mm, 400 nanometers, to 0.0007 mm, 700 nanometers, depending on the colour of light. A visual representation of this process is called refraction. Focusing a concentrated beam of light through a triangular prism will cause the different colours to disperse in different directions. Characteristics of a visible light wave consists of the wavelength, determining the colour, and amplitude, determining the intensity or brightness. The wavelength is measured from peak to peak, or trough to trough. The amplitude is measured from the equilibrium to the peak. Visible light travels in transverse waves at a speed of 3.0 times 10 to the power of 8 meters per second, also known as 299,792,458 meters per second in a vacuum. Formula. As mentioned previously, formulas were used to calculate the behavior of a wave at a specific point in time. They can also be used to determine how much power is needed per lighting fixture or rig, as well as the distance light will travel. Here are a few examples of calculations used. Algebra. The use of letters as constants in a calculation. This is to show how we've calculated something. For example, E equals L divided by W. In this calculation, to find how much light a bulb produces compared to the power consumption, E stands for the efficiency. This is what we are trying to find out, how well the source produces light. L stands for lumens, the unit produced to measure brightness of the lamp. W stands for watts, the unit used to measure the power used. Ohm's law. Expressed in an algebraic formulation, Ohm's law is used to determine electrical circuit characteristics. E equals IR, where the current resistance is used to calculate the voltage. Pythagoras' theorem, a squared plus b squared equals c squared, can be used to determine the throw distance of a light, measuring straight down from the light source and where the light is being directed, like a stage, and substituting the a for the height from the floor to the level of light and b for the length from the light to the stage. Then square rooting a squared plus b squared, the throw distance can be calculated, the square root of c squared. Mathematical equations and rules can also be used for lighting design. For example, the use of trigonometry and geometry for angles light should be positioned, along with how many will be needed to light a space. Based off the light's size and brightness, using slide rules, tape measures to measure lengths, protractors for angles, calculators for determining calculations, and computer software or graph paper for designing lighting layout. Perception. So visible light comes in lots of colours, but how do human eyes see light? The human eye is made of a few important parts. These include the cornea, the pupil, the iris, the lens, the retina, and the optic nerve. When light reflects off an object, it enters the eye through the pupil. Behind the pupil is the iris. The function of the iris is to contract and relax, to change the size of the hole, to let different amounts of light into the pupil. Once the light has entered through the pupil, it is refracted by the cornea onto the lens. The lens focuses the light into a single direction, towards the retina. The retina consists of many different light-sensitive cells called rods and cones. Up to 125 million rods used for dim light, and 6 to 7 million cones used for distinguishing colour. There are 3 types of cones in the retina's light-sensitive layer, each sensitive to different wavelengths of colours: red, blue, and green, the primary colours, which are used to mix all the assorted colours we see. These are often referred to as RGB, red, green, and blue. and CMYW, cyan, magenta, yellow, and white. It is then transferred into electrical energy and sent to the optical disc, the end of the eye and the start of the optic nerve, where the electrical energy is sent in impulses along the optic nerve to the brain for processing into an image. First lighting. Lighting was not always diodes and tubes. Beginning at the start of time, it was prehistoric humans who discovered artificial light as a byproduct from a flame. This was called pyroluminescence. The amount of light depends both on the temperature and the fuel being burnt. For example, a flame burning at 50 degrees Celsius with petroleum as the fuel does not burn as bright as smokeless coal burning at 150 degrees Celsius. Dating back to almost 1 million years ago, the first fire was created from the friction produced by rubbing together wood and kindling stone and flint. An example of one of the earlier controlled fires from 1 million years ago is the campfire's remains of a South African cave. Once they knew the flame of fire emitted light, they were able to invent the first lamp around 70,000 BCE. Early humans created the first lamps by filling hollow rocks, shells, and other natural objects with moss, soaking the moss in animal fat and igniting it. These crude lights are known as animal lamps. The type of light paved the way for a new type of lighting source, the candle. Middle Ages. Around 200 BC, 5th century, the first candles were invented. Used in ancient Egypt, these candles were quite different to modern candles, created by dipping reed, a type of grass, in melted animal fat. The animal fat would then go hard and burn for longer periods. The Viking Age. From the 9th century, inventors adapted the current animal lamp with different fuels, such as vegetable oils and tallow. Working with the same principles of creating light, the burning of a fuel, innovators set to find easier ways to produce the light they needed than having to hunt for animal fat. This meant that many types of oil were tried, not just the few listed above, all encased in a new metal encasing, made from either tin, bronze, silver, or gold. Medieval lighting. Around the 13th century, lighting started to become more decorative, as well as for practical lighting. Using improved candles, these are now more comparable to modern candles. Made from animal fat or beeswax, depending on wealth. Now with iron in use, the candles were held in more ornate wall and ceiling holders, like chandeliers. However, candles were not the only type of light to be used. Lanterns were still used for being able to still see whilst moving, as well as a flaming torch. A flaming torch was a wooden stick called a stave, with one end wrapped in a material which could be soaked in a flammable liquid, like animal fat. Based off the idea of fire, from the prehistoric times, this type of light was quite smoky, therefore the light emitted was often less visible or less bright than other forms of light. Victorian lighting. Until the start of the 19th century, the Victorian era, candles were used as the main source of lighting. A scientific breakthrough by William Murdoch saw the invention of the gas lamp. The gas lamp worked off a mixture of coal, gas, and oxygen in the air to produce a fuel called carbon dioxide, CO2, along with a few byproducts, with one being light. Due to the type of fuel being burnt, and the amount of energy needed to run this type of light, they are quite bad for the environment, releasing the same amount of greenhouse gas emissions as 1,100 cars a year. This statistic does not even factor in leaks and unburned methane released into the air. Other ways of lighting the gas include the gas mantle. This is a device which creates an intense white light when produced at the point of gas ignition. As well as gas lighting starting to take off, a way of lighting a single person on a stage has been invented. It was called the spotlight. Using limelight, hence the saying, under the limelight, the most lit and desirable part of the stage, Thomas Drummond produced a soft, direct light. Limelight is created by heating calcium oxide to extreme heats, producing oxygen and hydrogen. The incandescence created from this heating process can then be directed and focused into a specific place, making a spotlight. Used in theatres, this type of lighting inspired many more generations of inventors to create new ways of lighting various parts of a stage or venue. Like a spotlight is a searchlight with a high brightness source, so much so that it can be used in film projectors and film set lighting. The carbon arc lamp, invented by Humphrey Davy in 1809, worked by putting two carbon electrodes together, passing a high current between them, and drawing them slightly apart. A problem with the carbon arc lamp was that the light was created using extreme temperatures, therefore it got extremely hot. That is where the invention of the incandescent lamp arose, invented to solve the problem of high temperatures materials catching fire. A filament mounted either in a vacuum or in an inert gas, which doesn't chemically react with the filament, created bright light without getting as hot. Created by Joseph Swan, with help from Thomas Edison in 1878, this was the very first incandescent light bulb. What made this a bulb instead of a lamp was that it was the first lighting source to be made inside an enclosure space, which is either transparent or translucent. This was also the first light to be incandescent. This means that a filament glows when heated through electricity. Edwardian lighting. Now that the light bulb has been invented, this paved the way for many more inventors to create new types of lighting bulbs, beginning with the first advancement in the Edwardian era, the tungsten lamp. This lamp, made in 1904, produces a continuous, but not uniform, spectrum of light. Tungsten bulbs were used in non-intelligent fixtures by putting coloured gels over the lamp. You could change the colour of the light being emitted. The tungsten lamp is still being used today, although it slowly started to be phased out for more eco-friendly lighting, as halogen and bromine are not very environmentally friendly substances. Around the same time, neon tubes were invented with a low lighting output of only 0.3 lumens per watt. This type of lighting was used for signage for the first time in 1910, like neon tubes. It's the neon glow lamp. Invented and patented by Daniel Moore in 1917, this light is an incredibly low light output, giving a soft glow. This is a great light for decorations of vehicle indicators. Neon lights can be seen frequently at conferences today as a decorative light. With a lot of innovation during this period, the next bulb to be invented was the flash bulb. Used in cameras, this is the first time cameras did not have to use the sun as the light source. A bulb filled with this aluminium works on the basis of combustion using zirconium as the fuel. At the same time, the fluorescent lamp was being created. A discovery by Jacques Russell in 1926 found that light created an electrical discharge with a gas or vapor. 8 years later, a group of scientists were able to use this advancement to create a fluorescent lamp used in signage today. Unfortunately, the materials used to produce the light, mercury and phosphorus, are hazardous, and if they are released into the atmosphere, contaminate the environment. In 1980, the first intelligent fixture was created, with a scrolling colour wheel, pull ropes to move a pan and tilt motor, and an arc lamp. This lighting fixture by Shoko, before becoming very light, was first demonstrated to the band Genesis as a concept. This design then resulted in many new types of intelligent fixtures being created today. In 1989, an adaptation of the incandescent bulb arose, the halogen lamp. This lamp marks the first step along the journey towards an energy-efficient bulb. This incandescent light contains a halogen gas enclosed in a quartz capsule. The halogen reacts with tungsten filament, which then heats up and produces a light. The tungsten particles that burn off are then reused, making it last longer and therefore more energy efficient. In the late 20th century, a new variation of light was introduced, the LED, lighting emitting diode. First used in the event industry at the Savoy Theatre in London, the first high-efficiency light without containing half-full materials, originally only available in red. This light was based on aluminium indium gallium phosphide. A few years later, the silicon carbide used to make deficient green and blue LEDs was switched to gallium nitride to make an efficient blue-based LED. The LED reduces energy consumption by up to 85%, reducing waste and consuming less energy. This is the most environmental way to light an area so far. The present. With LEDs being so much more sustainable than the previously used lighting, halogen, the UK government is planning to ban halogen, with fluorescent to follow shortly after. In the UK, this is to help with the aim to reduce emissions and cut costs, as the shift to LED bulbs will cut 1.26 million tonnes of CO2, the equivalent of removing over 500,000 cars from the UK roads. Due to this, venues are slowly starting to switch to LED fixtures to become more sustainable. To keep up with intellectual advancements, LED bulbs are being used in both intelligent fixtures and generic lights. Real-world examples of being used as a replacement of tungsten can be seen in places like Nottingham's The Metronome and London's the Royal Opera House, along with venues outside of England like the Sydney Opera House in Australia and the Fox Theatre in America. This would reduce energy consumption, reduce the rate of natural resources depletion, and reduce carbon emissions, thus impacting the global sustainability agendas positively. The United Nations Sustainable Development Goals, established in 2015 with a goal of reaching by 2030, aims to end poverty, protect the planet, and ensure that by 2030, all people enjoy peace and prosperity. With Goal 7, affordable and clean energy, Goal 11, sustainable cities and communities, and Goal 13, climate action, relating to lighting innovation. However, the replacement of tungsten lights to LED can have limiting factors. For example, LED lights cannot accurately replicate the colour temperatures of tungsten, as it has a different dimmer curve, in which, as it goes dimmer, the light glows warmer. This is because tungsten is the only light, other than sunlight, capable of a full spectrum. Thanks for watching.